everyone, so today we will be doing some practice problems on giving systematic names per IUPAC guidance for simple alkane molecules with 10 carbon atoms or less in the parent chain. Okay, so let's get started with number 1. Rule number 1 is to identify the longest continuous carbon chain, or we call it the parent chain. So in this case, it is highlighted here. There are actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbon. So this will be has the prefix of DEC, and then ending of A and E. So DEC comes from the fact that there are 10 carbon atoms. A and E is basically the ending for alkane molecules, because in this structure there are only carbon-carbon single bond. The second rule is to number the carbon atoms in this highlighted chain, so in such a way that you will hit the substituents in the shortest way. So this is the substituents. This is what we call as methyl. Okay, so I would label this from the left to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so that we can hit methyl group in carbon number 3. So you would write 3 methyl decene. For the naming nomenclature, you are supposed to separate numbers from wordings by hyphen or dash symbol. And then between the methyl and decene, the alkyl group or the substituents and the primary chain or the parent chain, there's no space. So make sure that you use this guidance. Okay. Next, we will do number 2. Here, the longest carbon chain is pretty obvious, right? So it is highlighted like that. And there are actually 1, 2, 3, 4, 5, 6, 7, 8. So 8 oct with the ending of A and E, octane. And then the way you would label this is actually from the left to the right, because it will be the shortest way to hit the 2 substituents. 1, 2, 3, 4, 5, 6, 7, 8. So there are 2 of the same group here. So there are 2 methyl groups. So you would need to provide the location of the 2 methyl groups and the fact that there are 2 methyl groups. So here there are 3 and then 5. Since there are 2 methyl groups, it will be dimethyl octane. Okay? That's for number 2. Let's move on to number 3. For number 3, it is in a condensed form, so I would expand it a little bit so it's more visible for the parent chain to be found. So let's do this. In this C, there are actually 3 groups or more carbons bonded to it. Okay, now once you expanded it, it's more obvious what the parent chain is, and it is this highlighted. So for the highlighted parent chain, you have 1, 2, 3, 4, 5, 6 carbon chain. So this is hexane. And then the way you would number them is actually from right to left. So 1, 2, 3, 4, 5, 6. So on carbon number 3, there are 2 ethyl substituents. So it'll be 3, 3. Because there are 2, there will be a di prefix, ethyl hexane. Okay. Next, number 4. This is a little bit tricky. So for number 4, you would find the parent chain as so. as the band structure. This will be the longest. Okay. Now there are actually 1, 2, 3, 4, 5, 6, 7, 8. So 8 carbons. This will be octane. And the way you label it is actually should be from top to bottom because you'll hit the substituents right away. 2, 3, 4, 5, 6, 7, 8. So there is 1 ethyl group and 2 methyl group. So when you have ethyl and methyl or more than one type of alkyl group as the substituents, you should label or name it in alphabetical order. So in this case, ethyl will be named first or to the left of the name. So it'll be 4 ethyl, 2,6 dimethyl octane. Okay, so that is for number 1 through 4. Now let's continue with number 5. With this one, the longest carbon chain would be as highlighted. It's a bent parent chain. So here you have 1, 2, 3, 4, 5. 5, it would be pentane. Okay. And then the way you would label it from is actually from the top. 1, 2, 3, 4, 5. So on carbon number 2 and carbon number 3, there are 2 methyl groups. So 2, 3 di methyl pentane. Okay. Next is number 6. So for number 6, the parent chain is pretty obvious, right? There are 1, 2, 3, 4, 5, 6. So this is a hexane. Then the way you label it should be from left to right because it takes the shortest way to reach the substituents. And on carbon number 3, there are 2 methyl groups bonded to it. So 3, 3 dimethyl hexane. Alright, let's move on to number 7 and 8. So for number 7, the longest carbon chain should be this way. Okay, so there are actually 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 carbon, this should be nonane. And the way you number the atoms, doesn't matter if you start from the top or from the bottom, you will hit this carbon as carbon number 5. So on carbon number 5, there's an ethyl molecule. So 5-ethyl nonane. Okay. Number 8. So let's expand the structure on number 8 a little bit more. CH, CH, CH2, CH3, CH2, CH3, CH2, CH3, CH2, CH3. Let's highlight the longest carbon chain. So this will be the longest carbon chain. Okay. And there are 1, 2, 3, 4, 5, 6 carbon. So this will be hexane. And then the way you number it, actually doesn't matter if you start from left to right or right to left, it's the same. So let's label from left to right. You will hit number 3 and 4 with 2 ethyl groups, so this will be diethyl hexane. Okay, so this is number 5 through 8. So for number 9, the longest chain possible is this way. Pretty straightforward, right? And then the way we number it will be, so there are 6 carbon atoms, so this will be a hexane. And there's 6 carbon atom, and we would label it or number it. We would number it from the left to right. So on number 2 and number 3, they're substituents. So because number 3 is ethyl group, you would write ethyl group out first because of the alphabetical order, right? Number 2, there's a methyl. So 3 ethyl, 2 methyl hexane. Number 10, the longest possible chain is like so. Okay. And then the way there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a decene. And then the way you number it, it would start from the left to right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So on carbon number 3, you have an ethyl. And on carbon number 5, you have a methyl. So 3 ethyl, 5 methyl. Okay, and last but not least, the longest carbon chain would be actually a bent chain. The longest carbon chain. So for number 11, the longest carbon chain would be a bent chain, like so. And in this chain, there are 1, 2, 3, 4, 5, 6, 7 carbon atoms. So this would be a heptane. Okay, and the way you number it, it would be, so if you go from here, you would hit 1, 2, 3, this carbon, right? But this carbon is only bonded to one methyl group. But if you start from here, 1, 2, 3, this is the preferred way because you hit this carbon number 3, and this carbon is actually bonded to 2 other substituents. So you would pick this way and not the other way. Okay. So it would be 1, 2, 3, 4, 5, 6, 7. So there are two methyl groups on carbon number 3 and 1 methyl group on carbon number 5. So it will be 3, 3, 5, trimethyl heptane. So 3, 3, 5 trimethyl heptane. Okay, so that's for number 11. Alright, so this is all the practice problems that are posted on Canvas. Hopefully this makes more sense now that we're doing it together. If you have any question, feel free to email me, and I'll talk to you later. Bye!